Okay, our goal for this problem is to express the limit as a definite integral on the given interval. All right, so we know that a definite interval or definite integral means that we're going to have this symbol right here, and we're going to go from a to b. That's my best attempt at the integral symbol. And we know that a to b is right here. That's from a, that's to b. So we're trying to find out the formula, the integral formula for the area under a curve. Let's try it like this. So we have some sort of curve. We're trying to find the area under the curve from A to B. We're trying to find this area by doing infinitely many little tiny little rectangles, according to this formula right here. Infinitely many rectangles. This right here would be the base. Just kidding. This would be the height. This would be the base, but I'll explain that better in a second. So right here, you're going to have a function. And once you have that, that would be the same. That would mean the same thing as this right here. So our job is to get an answer that looks like that, with the dx at the end, like a dx right there. All right. So going back to this right here, I know that this formula is the formula for the area of a rectangle. So the delta x is the width. All right. So that's basically this distance right here. That distance right there is delta x. This is the width of your rectangle, any of those rectangles. Okay, there's your delta x. And I know the height is right here. Height. And the more general formula for all of this stuff above is the limit as n goes to infinity of the sum of, what am I trying to say? Man, I just wrote this thing wrong. This has to go, this should go right here. And right here, there should have been a I equals 1. I'm just gonna keep going with this. All right, so you have I equals 1 and an n right there. All right, so the height is represented by f of x sub I. All right, so that's like if we're doing right-hand rectangles, that'd be x of x sub 1, and I'm sorry, that'd be x sub 1. That's x sub 2, x sub 3. So these are smart input values. That, and this whole thing would be the height of the rectangle. So this is f of x of 1. That's the height, right? And then over here you have your delta x. Great. So all we need is to get basically this function right here. Well, we have it. Since this is our delta x right here, our function is this guy right here, pretty much. So we can say that our function, f of x, is equal to sine of x, so it's just a generalized function, not x sub I, over 1 plus x. So there's our function, and the definite integral, so the area under the curve of this function from here to here, so basically writing it like this, and I'll just copy this part over again and put it over here. And then I'll finish writing down this part because I didn't finish writing it down. 1 plus x. All right, so I just copy that down. It is literally, for the function part, writing the function that I just got right here. So just copy this part down again. So sine of x over 1 plus x. And then from where to where? Well, from 0 to pi. 0 to pi. And that's it right there.